Good afternoon, pilot teachers, and good afternoon, students. Okay, thank you. Sit down. Okay, I'd like us to, first of all, look at the information from the booklet, and we can double check on what we have covered so far and what we have completed. And then we'll move on to what I'd like us to look at for our lesson. Okay, we're checking now on those factors that affect temperature. And so far, when we started off with part 3 on the climate, we looked at generally climate can be described as the condition of the atmosphere averaged over a long period of time. It usually involves 3 features. And the 3 features that climate usually involves are temperatures, precipitation, and pressure. So we looked at the first of those features, and we looked at temperature. Temperature varies from place to place because of certain factors. And those factors are latitude, that is mainly to look at the distance away from the equator, the colder it gets, or if we are at the poles, it will be cooler. Coming towards the equator, it would be hotter or warmer. Then we also looked at altitude, which is to do with height above sea level. Another of those important feature is that of aspect, and that's what we have covered in our lesson or last lesson. We also looked at cloud cover. We looked at ocean currents and distance from the sea. Beside those 6 or 5 factors that are given in our booklet, I also included hotter in summer, colder in winter, and also hotter by day, cooler by night. We have basically covered all of those features that we need to look at, especially the factors which contributes to what makes temperatures different from one place to another. And the last of those that we are going to look at today is basically to look at pollutants in our atmosphere or in the atmosphere. But before we go ahead to looking at pollutants in the atmosphere, from our last lesson, we looked at aspect, and the definition given to what aspect is, it is generally the direction in which a slope faces, especially in the context of exposure or different degrees of insolation. Aspect is more common in the high latitudes or the temperate regions. We had 2 diagrams to illustrate or to show what happens to the northern slope and the southern slope of hills or mountains, especially in the temperate latitudes. In the northern hemisphere, the south-facing slope will tend to receive more sun's energy compared to the south-facing slope. Sorry, I'll repeat that. In the northern hemisphere, the south-facing slope will receive more sun's energy compared to the north-facing slope. Therefore, it will be hotter in the southern slope compared to the northern slope. Meanwhile, in the southern hemisphere, the north-facing slope will receive more energy or more of the sun's solar energy compared to the south-facing slope. Therefore, in the southern hemisphere, the northern slope will be hotter compared to the southern slope. And that is what we have covered on the work on aspect. Okay, we had some pictures or photographs generally to show the concept or the idea on aspect. And here we are looking at perhaps an area in the Arctic region. You can see one section of the landform here, which has been heated up, and the other side in actually shadow. If we had to look at difference in temperature, the lighted area will be warmer compared to the area that is in shadow. Another example that we looked at, buildings generally in a city, you can see the lighted area where the buildings are directly exposed to the sun's light, and then you can see the shaded areas where the sun's energy is actually not directly heating up. So one could say generally that these areas would be hotter or temperatures would be higher in comparison to those areas that are not directly exposed to the light or the sun. I also mentioned something about people who are responsible for building or putting up buildings, maybe architectures, when they're also building, they have to be cautious and also be aware of the distance that they are putting up their buildings, especially if they are considering the angle of the midday sun and how much of the sun's energy they would like to actually be maybe used, not only used, but also for heating up of the different buildings. In the high latitudes, because of the fact that the angle of the sun is a little bit lower, we note that the buildings will tend to be built further apart. Whereas in the tropical latitudes, or the low latitudes, because the sun is directly overhead, the angle of the midday sun is a bit more vertical compared to in the high latitudes. Therefore, the distance between the buildings does not have to be far apart as in comparison to those buildings in the temperate latitudes. Okay, and generally that is what we have covered on the last of those features, which we will find in our book, and that is on aspect. Anyone with any queries or questions that you'd like to ask before we move on now to pollutants or pollution and how they can contribute to variation in temperatures? Any questions, perhaps on any of those features that we have covered, starting from latitude down to the last of those that we looked at, which is on aspect? Any questions? Okay, I'm pretty sure perhaps in your exercise book also you are up to date with your note-taking, and you do have diagrams in your exercise book to help you with explanation of some of those features or factors that we have looked at, which contributes to what makes temperatures different from one place to another. Okay, if there are no questions, then today we are going to move on now to looking at the last of the features or the factors, and that is on pollutants in our atmosphere. Most of the information that we are going to look at from the monitor, especially the writing, I would expect you to listen and summarize briefly. I don't want you to copy every single word by word that is actually on the monitor here, because most of what I'm going to give you, you should already have known about, and you can summarize later on and put it maybe in 1 or 2 sentences to explain basically how pollution can contribute also to variation in temperatures. One of those guesses, we are now moving on to looking at pollution now and how it affects temperature. And one of those main gases that we are going to basically look at in our lesson today will be carbon dioxide. So when we are dealing with carbon dioxide now, as one of the pollutants which can contribute to variation in temperatures, one can say that on its own in the natural process, carbon dioxide is not a pollutant. Because in the natural processes, carbon dioxide is essential. It is present in the atmosphere. But it becomes a problem if too much of it is actually put into the atmosphere as a result of the burning of fossil fuels, fumes from factories and industries, even from vehicles. Those are ways in which we can increase the level or the amount of carbon dioxide in our atmosphere. Therefore, if there is too much carbon dioxide in our atmosphere, it becomes a problem. And one of those problems that we are very much aware of today is that of the greenhouse effect. So let's look at the greenhouse effect as one of the examples now to do with pollutants in our atmosphere. Okay, the greenhouse effect. I'm going to read through the information presented on the monitor. Again, I'd like you to listen, and if you do have to take notes, please summarize or only take the main points down. Do not have to copy everything which is on the monitor. First of all, looking at the greenhouse effect. A glass hothouse or greenhouse is used in some colder parts of the world to grow flowers and vegetables. The glass lets the sun's rays in. They are absorbed by water vapor, and the heat is trapped inside that particular glass house. The glass house, therefore, stays warm even on cold days. The atmosphere, in the same way, lets the sun's rays in to hit the Earth's surface. As the rays pass back through the lower parts of the atmosphere, they are easily absorbed by water vapor and carbon dioxide. As in a hothouse, the heat is trapped and it warms the Earth's atmosphere. We have already looked at that when we covered insolation and also how the atmosphere or the Earth is heated. What are the three ways in which we can look at to say how the Earth or the atmosphere is heated? What are the three ways that we have looked at on how the atmosphere or the air around us is warmed? Doreen, at least give me one of the ways in which our air can be warmed. Solar radiation coming through the surface. The Earth gets to be heated up mainly from insolation, the 50%. And from insolation here, we're looking at the three ways in which heat is used to heating up, or the energy is used to heating up our air and the atmosphere. Doreen? No? Kiran?
Radiation, conduction, and convection.
Okay, very good. So we're looking at, as in the hot house, the heat is trapped and then it warms the Earth's atmosphere. And it warms the Earth's atmosphere through the process of radiation, conduction, and convection. And that is what we have already covered on how the air is actually warmed. When we look at the heating up of the atmosphere, this then is known as the greenhouse effect. There is also a growing concern from scientists that human activities have or has greatly increased the greenhouse effect. Each year, the burning of fossil fuels like coal, oil, and natural gas releases many billions of tons of carbon dioxide into the atmosphere. Together with the other greenhouse gases like the chlorofluorocarbons from aerosol sprays, the nitrous oxides from fertilizers, and methane from livestock and industrial processes, the buildup of carbon dioxide is trapping more of the sun's rays, and that is causing higher temperatures on the Earth. When we look at the greenhouse effect, it's also important for us to know some of those greenhouse gases, which does contribute then to warming up of the Earth's atmosphere. And the greenhouse gases are carbon dioxide. Carbon dioxide mainly comes from the burning of fossil fuels in power stations, from petrol engines and factories. Also, the burning of forests accounts for about 10% of the carbon dioxide added to the atmosphere. Another of the greenhouse gases is that of ozone. In the lower atmosphere, formed by chemical reactions between car exhaust emissions and sunlight. That's the source that we are looking at for ozone. Then we also have methane as a greenhouse gas, mainly from animal waste, rice paddies, gas and coal rubbish, rubbish dumps, and also wetlands and swamps. Another greenhouse gas, the nitrous oxides, mainly from car exhaust, and nitrate fertilizers. Then we also have the CFCs, or the chlorofluorocarbons, and that's where we have sources from aerosol propellants, refrigerator fluids, air conditioners, and foam packaging. Those are some of the sources as well as the main greenhouse gases. Any questions up to that point so far? No questions? Okay, we'll move on. Let's look at a simple diagram to show us the impact of the greenhouse gases and how they contribute to temperature differences. This first diagram here shows us the low level of carbon dioxide in the atmosphere, or generally in the natural process, whatever carbon dioxide we have present in the atmosphere. Sunlight comes through, hits up the surface as insolation, and then we have from insolation the process of radiation, conduction, and convection to heat up the atmosphere around us. Because of the low level of carbon dioxide in the atmosphere, what happens is that extra heat does get to pass back into outer space, resulting then in a balance of heat within the atmosphere. The first diagram. Let's look at the second diagram. In the second diagram now, you can see where the forest was, as in the first diagram, a lot of it now has been cut down or destroyed. Therefore, because of the destruction of the rainforest and also grassland, there is less carbon dioxide now for the process of photosynthesis. Factories also, today with the Industrial Revolution, would have contributed large amounts of carbon dioxide into the atmosphere from the processes that are involved in the factories. As a result of that, the same energy from the sun coming through, heat then, which is being released, is actually trapped. So instead of going right out into the atmosphere, the heat gets to be trapped then by the high amount of carbon dioxide. So what happens is the trapping of the heat means that the area becomes more hotter. As in comparison to the first diagram, where a lot of heat gets to escape back, resulting in a balance. So the problem today, the increased number of factories and industries, we are destroying more of our rainforest than trees and vegetation. And as a result of that, the content of carbon dioxide now is increasing, and it is forming a blanket or an umbrella-like over, which is not allowing the radiation and conduction and convection or the heat from the surface to escape. Rather, the heat is being trapped inside, resulting in the warming. I'll stop here. What I'm going to ask you to do now is, into your exercise book, I would like you to explain in your own words how carbon dioxide gases, as well as pollutants in the atmosphere, contributes to the greenhouse effect. I would like you to use a diagram or to illustrate your explanation with a well-labeled diagram. So I'll repeat my instruction again. Into your exercise book, with the help of a well-labeled diagram, you explain how the pollution in the atmosphere can contribute to the greenhouse effect. is the monitor. Are they focus on the monitor or? I can. Like to move in or something. Or we are chilling a bit, so I walked to check on the other stuff. Okay. move in a bit so that I can pass through here. Let me check. Okay, I'll contribute to the greenhouse effect. Large factories contribute increase of CO2 into the atmosphere, CO2 present, excess loss of radiation. Okay, that means you have to write a little bit so that it explains a little bit more on what you have put on a diagram. So in maybe one paragraph, 1 or 2 sentences. Cutting them. You'll have to improve your diagram a little bit later on. Put in some colors and make it a little bit more distinctive. Okay, most students are actually working on getting their diagrams constructed, and don't forget, beside a well-labeled diagram to explain how the greenhouse effect does have an effect on the temperatures, you're also supposed to write an explanation. If your diagram is well labeled, then perhaps it will explain itself. But if it is not well labeled, then I will expect you to write a paragraph to explain or to go together with what you have written or constructed on your diagrams. Okay, let's look at the information presented here, perhaps to help you, and then that will also serve as a summary to finish off what we are doing on pollutants in the atmosphere. And whatever you don't complete then, you will be required to complete that for your homework. Let's look at what we have covered so far on the greenhouse effect. The reason for why we're looking at pollutants is because definitely pollution in our atmosphere can contribute to variation in temperatures. Looking at the greenhouse effect, carbon dioxide or CO2 is a natural part of the air we breathe. In normal circumstances, energy from the sun is absorbed by the earth as heat. And most of this heat is radiated away from the earth. Some warms up the atmosphere, some escapes back into space. So if we have a simple diagram, this diagram here will show that the yellow color coming in through as solar radiation, we have insolation, the heating of the surface, and some of it actually radiating back into space with the arrowhead pointing out. When we talk about the greenhouse effect, for the last 100 years or so, the increasing use of fossil fuels has put more CO2 or carbon dioxide into the atmosphere. And this has raised well temperatures by about 0.5 degree Celsius, as carbon dioxide in the air absorbs more of the heat radiated from the earth, so the warming up of the atmosphere. So now we look at the diagram again. With industries and all that, radiation, amount of heat coming through, instead of that amount going back, what is happening is a lot more of it is remaining. There are fears that carbon dioxide continues to build up in the Earth's atmosphere. Wood temperatures or well temperatures, will continue to rise. This could have disastrous results, and some of those would be ice caps at the poles could melt, and flood many parts of the world's coast that are presently above sea level. In other words, more carbon dioxide into the atmosphere, ice in the North and the South Pole could melt, resulting then in more water put into the oceans, a rise in sea level. Low-lying areas, especially in the coastal regions, can become drowned as a result of the rise in sea levels. In Papua New Guinea, already we are experiencing or having perhaps the effect of the greenhouse effect, and that is looking at some of the islands in the North Solomons province. The Carteret Islands, Motlok Islands, those are being affected as a result of the rise in sea level, and a lot of people have been evacuated or moved so that they are not affected should anything happens in those particular low-lying islands in the country. Okay, so one of the impact of the greenhouse effect then would be rise in sea level as a result of the melting of the ice in the North and the South Pole. So your diagram that you're constructing should be well labeled, and the diagram should show us the solar radiation coming through the surface, and it should also show us the levels of carbon dioxide in the atmosphere and what happens when heat is being re-radiated back into space. Because of the amount of carbon dioxide, not all of it is escaping back, and because of that, that is contributing to the heating up and the increase or the rise in the temperatures. Your diagram should be able to portray or to show that. Okay, I think with that information, class, that is also the end of our lesson, and that should also summarize and conclude what we have been doing on factors which contributes to what makes temperatures different. If you can stand up now, please. To the pilot teachers, the keyword for lesson 108 is greenhouse. Good afternoon and thank you, students.